All right, in this video, we're going to talk about one of the homework problems. It says on which one of these domains would the function pictured here be a one-to-one function? And then they list a bunch of possible choices here. 1 to 5, 2 to 8, negative 2 to 5, 1 to 4, negative 4 to 2, and 0 to 4. Okay, so just a quick reminder of what a one-to-one function is and how we would tell a function is one-to-one from the graph would be through the horizontal line test, right? So what we would do is imagine a horizontal line somewhere, and we want to look at how these horizontal lines intersect the graph of the function. And so here we can see that this horizontal line doesn't intersect the graph of the function at all. And then up here, the horizontal line is going to cut through the graph or intersect the graph in more than one spot. So whenever you have that situation where a horizontal line cuts through the graph in more than one spot, that means that the function is not one-to-one. Basically what it means is that if we had the formula for this function and we plugged in a negative 2, we would get 3. And if we had a 6 and we plugged that in, we would also get 3. So with a one-to-one function, you can't have that. All right, so this graph, the one that's pictured here, is not one-to-one because it fails the horizontal line test. There's some horizontal line, in fact a lot of them, that would cut through the graph in more than one point. Okay, so this is not one-to-one. So what they're asking us is that if we only looked at the graph over this part of the x-axis, then would it be one-to-one? Okay, so that's what they're asking. So what you have to imagine is if I only did the horizontal line test with this piece from 1 to 5, would that pass the horizontal line test? In other words, would every horizontal line cut through the graph in 0 or 1 spot? So when you're doing this on pencil and piece of paper, you just kind of have to imagine it yourself, restricted down there. But on Desmos, I can restrict it down pretty easily. So that's what I'm going to do. I'm just going to look at this piece from 1 to 5 and then ask myself, okay, would that graph pass the horizontal line test? And the answer on that would be no, although it's really hard to get in there, and I don't really want to zoom in too much. Let's see, what would that, let's say something slightly smaller than we really have to kind of get close to 5 in order for that to fail. All right, so here we are at this horizontal line. Man, that's really hard to see, but that horizontal line, let's see if I take it off projector mode, it's still hard to see. But yeah, if I had this horizontal line through here, it would cut through the graph in this spot right here and this spot right here. So the answer on this one is nope. It would not be one-to-one on that piece right there. All right, let's move on to the next one. And that one is from 2 to 8. So if I restricted it from 2 to 8, okay, and then now thought about the horizontal line test, right? Looked at how horizontal lines intersect the graph. Down here, there's no intersection points, and up here, this is fine, right? The horizontal line is just intersecting the graph in only one spot, and same thing here, and even up here at the top, that's fine. It only intersects right at that point at the top right here. And I can't quite get it to go on there, but right there at 2,5. It only intersects at that one spot. And so that would mean that yes, on this piece, if I only looked at the original graph on the piece from 2 to 8 on the x-axis, then it would be the graph of a one-to-one function. All right, next up, negative 2 to 5. Right, that would be that piece, and clearly the answer here is no. That would not be one-to-one on if we restricted it to that piece of the x-axis because there are going to be plenty of horizontal lines that cut through the graph, right, in more than one spot. All right, -1 to 4 is the next one. And here again the answer is going to be no, right? Here's a horizontal line that cuts through the graph in 2 places, so not 0 or 1. And so therefore the original graph restricted to that piece, oops, is not 1 to 1 on that piece. All right, next up is -4 to 2. Okay. All right, so now looking at the horizontal lines on that piece, that's fine. Those horizontal lines are fine. They cut the graph in one spot. That's okay. And then right here, it would just be that one point up at the very top. And then up here, there would be no intersection points, right, for those horizontal lines. So the answer here is yes to that one. All right, and finally 0 to 4. And here the answer is going to be no, right? Because here is a horizontal line that intersects the graph in more than one spot. So the answer on that one is no. Okay. Oops, our original one was to 8 here. I think -2 to 8 maybe, something like that. Or maybe it was -4 to 8. So yeah, so those would be the answers on those. So you have to kind of imagine the part of the graph, and you can kind of see after doing these examples, right? Really the key thing is this point right here, it's sort of the top of the U right there. If you have some points in the domain that are to the left and also some points that are to the right of 2, that point right there on the x-axis, well then what's going to happen is that when you look at the vertical lines, there's going to be 2 intersection points right there. Whereas if you only have points to the left of 2 in your domain or to the right of 2 in the domain and not both, then it is going to be 1 to 1. So if you notice, right, all of these ones that all of the answers that were yes, there was only points to one side or the other of this high point up here, to the right or to the left. All the answers that included some points to the left and some points to the right of that, the answer was no. And so that's it on this problem.